All right, everybody. This is the Thursday lecture. As you can see, it's Friday, wrong time as usual. Um, but this is the lecture for week 6, second lecture. If you look in the web browser, of course, if you look in here, you'll see that week 6, we have lectures for week 6. And in there, on Thursday, there is a set of lecture slides here, and I've already got them open here. And yeah, we'll go ahead and look at this. I have pictures in here from MATLAB. Um, Maybe I'll open Octave as well, and we'll go ahead and get started here. So yeah, let's get right into it. So last time what we were talking about was relational operators, I think, is where we left off. So this was in section 4.3 in your textbook. Why is this so wide? So we were in section 4.3 in the textbook, and that covered relational operators, um, which we've already done. So done. And it also covered logical operators, which we're going to talk about now. Okay. Um, and then also we're going to look at section 4.4, which is branching. And specifically, we're going to be looking at if statements today. So this is good. This is real programming, finally, right? It took us a long time to get here. That's how introductory programming classes are, especially this one on MATLAB, because MATLAB is not just a programming language, right? It's also a program that has a lot of built-in stuff for us to use. That's why we had to do plotting and things like that. Um, anyway, let's get into this. So it's like okay, whatever. So yeah, let's get right into it. So what we had done last time was we looked at relational operators, and relational operators are these guys, right? Like x less than y, x less than or equal to y, x greater than y, x greater than or equal to y, x equals y, equals, and x not equal to y. Okay, and so those are the normal things that we use all the time in this programming language and every programming language. Um, so I think they're mostly self-explanatory. The couple at the end are a little bit confusing. We'll talk a little bit more about them right now. But if you're just trying them out, right, you can open, let's open Octave here, clear the screen. They're easy to try out, right? Like if I say 3 less than 7, then I get 1 because 3 is less than 7. If I say 3 greater than 7, I get a 0, right? Because 3 is not greater than 0. And so we get a 0 for false and we get a 1 for true. So we learned about this all last time. So we're not going to um, spend a lot of time looking at that at the moment. But there is something that we do need to look at, and that is we need to be careful using the equality operator, check for equality, equals, and also the not equals operator. Um, when we're using decimal numbers, we have to be careful. Now, with most programming languages, you have different data types. So in a lot of programming languages, you have integers and you have like floating point numbers. So maybe I can actually just show you this, I think. Um, well, I guess there's no point. So I was going to show you something in another programming language, but it's useless. Um, so the point is that you have to be careful because in MATLAB and Java and everything else, floating point numbers, which are our decimal numbers, are not exact. So we only have, let's say, 16 digits of precision. That's about what we have. precision. So that's not very much. Well, I mean, it is, but it's not enough, I guess, is what I should say. Um, enough. Now, what do I mean when I say it's not enough? When I say that it's not enough precision, what that means is that some things that should be equal end up not being equal because of the non-exactness, right? So mathematically they should be equal, but they're not. So like when we do pi, like in octave, if I do format long so I can see all the digits and I say pi, this is what we have for pi. But we know that pi goes on forever, right? A lot more than that many digits. But this is all we have in octave or in MATLAB because that's what you get with a 64-bit floating point number, a double. Um, so that's not exactly pi. Now, the problem with that is this. If I go to calculate something like sine 0, I get 0, right? I go sine 0, and it says 0, no problem. Because 0 is exact, and the sine function is going to be correct up to as many digits as we can have. So we just get sine of 0 is 0. That's exactly what we want. However, in math, sine of pi is 0 as well, right? Sine of pi, sine of 2 pi, sine of 3 pi, any integer multiple of pi, the sine will be 0. But if I do sine of pi here, I don't get 0. I get 1.222, whatever, e to the negative 16, which means that that number, when I actually do sine pi, what I actually get on the computer is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then whatever we had, which was 1, 2, 2, 4, 6, etc. So like 1, 2, 2, 4, 6, something like that. So this is the number that we get. And this number is not 0, right? It's really, really close to 0, but it's not 0. And that's a problem when you're using the operator equals equals, right? Because you might be checking if they're equal to each other, right? Sine 0 is equal to sine pi mathematically. But if you do this on octave or in MATLAB, if I say sine pi equals sine 0, that should be true, but it's false. And we just saw why. It's because the sine of pi is not actually 0 in MATLAB or octave. It should be, but it isn't. Okay. And so the way we deal with that is this. So this is just what we just saw. Um, so what do we do about it? That's kind of the punchline. And so what you do is you just have to be aware that this issue exists, and generally do not, if you can help it, check if a floating point number, a double, which everything is in MATLAB, is equal to another one. So in general, that's the way you solve this problem. In general, don't use equals and not equals, which is this way, not equals, um, on double data types, which is basically all we use in MATLAB. Okay, so you can use it, it's just not recommended. You will occasionally run into trouble if you try to do this. So what would we do instead? So instead, we would use a command like this command right here, where I say ABS. ABS is just absolute value. Let me go to let's go here. Um, so got MATLAB opened here. So we know this. If I do sine pi, it's, and I do equals equals sine 0, then we get false. It's not true. But they are very close together, right? So the way that we check if they're very close together is we say, well, if you subtract them, the number will be small. So if we take the absolute value, so the reason we're doing absolute value is because, like, for example, if we have a number like this, right? Oh, that's not how numbers work. If you have like a number like this, um, we want to just drop the negative off of it and just make it positive um, for the comparison to work. And so basically, if I were to subtract these two values, whatever we're trying to compare, so sine, right now I'm comparing sine pi and I'm comparing sine 0. So I just subtract them and I put the whole thing in an absolute value like that. That number is going to be very small, right? It's actually going to be that big because that one's 0. So that's going to be very small. So what you do is you subtract them and then you say less than, and instead of putting, 0 here or equals 0, you put just a very, very small number like this. So is the difference between these two numbers less than this very small number? And the answer there is true. So you can use an expression like this in order to check if two numbers are really close together. Just replace the sine pi and the sine 0 with whatever two things you're trying to check. And then how close together you want them to be, that's what goes on this side. So for example, we know that with the sine pi that we just did, that it's about this big. And then we have this 1, which is then the 16th digit, right? So if we know that the 16th digit here might be off, then maybe the 15th or the 14th digit are correct. So it's zeros that far, right, to the part that I highlighted. My mouse is not working. So you would be able to use something like this, like 1e, and you could use whatever you want, but like -14, for example. That would be saying, are they correct to like 14 digits, 14 decimal places? So if these are the same to 14 decimal places, then we can probably call them the same, right? So you have to use this complicated expression like this instead of just the simple equals equals. Okay. Um, Here I used e to the -10. Remember, e is just scientific notation, so that's e to the -10 is is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 zeros and then the 1 there is what that is. So that's how you can check for equality. Okay. Um, what else can we do? Well, you can check if two things are not equal with the exact same idea, but what you do is you just flip around the less than there to a greater than, and then you'll be checking if they're different. So same means less than a little number when you subtract them. So subtract them, and it's less than a little number. And if you're checking if two things are different, so you're checking if they're not equal, then you do the exact same structure, but you put a greater than and then whatever you want there. Um, so it's always an absolute value, subtract the two things. It doesn't matter what order you put them in because the absolute value will make it positive no matter what, and switching the order just changes the sign. Um, and then however close you want them to be, or however far you want them to be, you put that here, and it should just be a little number. Okay, now that's going to be relevant later on in this class. It's not like really relevant now. It's just, we can refer to this later, that this is how we compare floating point numbers, decimal numbers. All right. So with that said, let's talk about new thing, logical operators. So logical operators are what we use when we have multiple conditions that we all want to check at the same time. So like the example that I gave here is, let's say that I want to know if x is less than y and if y is less than z, right? So I have two things to check: y less than z, uh, y less, well, x less than y, and less than z. So individually, we have these two conditions, right? X less than y less than z. And then how are we going to stick them together to check if they're both true at the same time? Well, this is how we do it in MATLAB. We use and. So ampersand, ampersand. So that's on your keyboard, right? Above the 7 on US keyboards, above the 7 key. So shift 7 basically. And we have x less than y less than z, and. And what's the and do? It will check if they're both true at the same time. And we'll look at a table of these in a minute. But just to show you, over here in, I guess, MATLAB, here's MATLAB. So just to show you over here, if I say like 3 less than 5, right? Oh, oops. 3 less than 5, that's true. And if I do like 5 less than 7, that's also true, right? And so if I do 3 less than 5 and 5 less than 7, what do I get? I also get 1, which is true. So this is true, right? Now, if I change one of these to being false, so 3 less than 5, which is true, and now if I say 5 less than 1, this one's false, right? So now this is a true and this is a false. And so when I run this, I get false. Why? Because what and does is checking if both of them are true. Both of them at the same time are true. So if one of them's false, the whole thing will be false. All right, so that's an example. If you want to check if two things are true at the same time, you use and. Um, here's kind of a table of what our choices are for these logical operators. So you'll see that there's more than I just mentioned. So we have and, which is a logical and. We have and, which is what I just used. They call that logical and with shortcut evaluation. I'll explain that in a minute. We have or, that's just a vertical line. Where is the vertical line? That is above the backslash key on a US keyboard. So like if I do keyboard photo US, we've done this before. Here's a keyboard that'll work. So what are we looking at? So your ampersand is right there on the 7 key. Your vertical line, which is sometimes called the pipe symbol, is over here, right? So backslash is right there, and then above it you have the pipe symbol, which is, so you press shift and then you press that, and you get the vertical line. So and is here, pipe symbol is here. All right. So back here, that's how you get those. And again, one of them is logical inclusive or. We just normally call that or. And two of them is or with shortcut evaluation. And then we have two more down here called exclusive or, XOR, and also not, which is a tilde symbol. Now, we'll explain these. So let's do that. So here's the explanation for how these work. So when you do and, or if you do and, either of these, so the result of an and operator is true if and only if both inputs are true. If either or both operands are false, the result is false, right? So we saw that in MATLAB when I typed it, right? Like I made this one false, and because this one was false, the whole thing was false. So one false makes an and false. Also, two falses make it false. So if I do uh, 3 less than 0, which is false, and 5 less than 1, which is false, that's also false. All right. So the difference between the double ampersand version and the single ampersand version is just how MATLAB will evaluate them. So they're the same operation. That's not true in Java, by the way. So like in other programming language, in some programming languages, um, and can be very different. In MATLAB, they aren't really. So they're what I'll just say they're pretty close. So the difference between them is how they are evaluated. So when you do P and Q, for example, I just put symbols there, P and Q. Um, we know that if one of these is false, right? The P or the Q is false, the whole thing will be false. So when MATLAB is evaluating this and it's just going left to right, so it's going checks the P, then it checks the Q. Um, if it checks the P and P is false, right? Then there's no point in looking at the Q because as soon as P is false, the whole thing is known to be false. It already knows what the result is. So um, if it sees that P is false, it will not bother reading the Q at all. So it won't look at Q. Um, that's the shortcut evaluation that they mentioned in the table here. So when it says with shortcut evaluation, that's what it means. It checks it left to right. So if the first one's false, there's no point in looking at the rest of it. So it doesn't. When you do the single and version, then it will check the P to see if it's true or false. It will check the Q to see if it's true or false. And then it will do the comparison. And so the point is that the Q will always happen. Now, where would that matter? I don't know. Maybe you can put a function here, right? Like what if you do like um, sine one and sine three, right? Like you can do that. Um, but what if this is really slow to calculate? Now I know that sine is not slow to calculate, but what if sine was really slow to calculate? Then maybe it would be faster to do this version because it'll check sine one. Well, actually, I guess this would be a more accurate one. So if you do sine zero and sine three, um, then it will check sine zero, see that sine zero is zero, which is false. So it does not need to check sine three. Um, and so if sine three was slow to calculate, then writing this would run faster than writing this, even though the result is the same. Because in the second version here, the sine 3 gets calculated no matter what. In the 2and version, sine 3 does not get calculated because we didn't need to. All right. There's other versions or other differences as well. So it says here that and works with scalar or array values as long as the sizes of the array are compatible. Um, we will see that when we see it. We don't need to look at it right now. All right, now which one do you use, and or and? It doesn't really matter most of the time. People usually use and. Um, and is what other programming languages use anyway. And so, like if you're copy pasting code, the and version will make it easier to copy paste between programming languages. So that's kind of why people do it. But it doesn't matter much. All right, next thing, logical or. So or is like this. So this is an inclusive or, that's the regular or. And so it's true if either or both of the inputs are true. So either or both. So like if I go to MATLAB here to check this, if I go true or false, that's true, right? True or false is true. If I do false or true, that's true. If I do true or true, that's true. So true or true, true. False or true, true. True or false, true, false, or false, false. Okay, so the only time this is false is when you have a false or false, right? That's the only time this is false. And that's what logical or does. Now you're probably thinking, usually people mean like when they talk, usually people, when they say or, so people say or, they mean one or the other, but not both, right? Like if I say this, like if I say I'm going to eat pizza or a cheeseburger, um, you probably don't need mean you're eating both, right? Or I guess it's me. I probably don't mean I'm eating both, right? But that's an English thing, right? In programming, pizza or burger, that can mean both. Both of those is fine. Okay. And if you mean one or the other, but not both, that's a different logical operator. Okay. So, yeah. So the other thing about logical or is that, so for the shortcut evaluation, it's exactly the same as and. So if you do the double version of it, so or, pipe symbol, P or Q, if it checks the P and the P is true, we know the entire thing will be true, right? Because if there's any trues, logical or will be true. So it doesn't need to look at the Q. So if the P is true, it won't check the Q. If you do the single version of this, then you do not get the shortcut evaluation, and it'll evaluate P and it'll evaluate Q. So if Q is slow to evaluate, for example, then this version will run slower. All right, so now this is the one that works like um, English works, right? So let's go back over here to the notepad, right? So if I do this, like if I do pizza or ah, pizza or burger, right, is true if pizza is true or burger is true or both are true. That's what we decided. Now, if you want one or the other, that's this one, XOR, pizza burger, right? This is true if two possibilities. True if pizza is true and burger is false, or if burger is true and pizza is false. And so the point is only one of them. So if you do uh, pizza is true and burger is true, then XOR, exclusive or, pizza, burger is false. Okay, so um, exclusive or means either the pizza is true or the burger is true, not both. Okay, so here it explains it better. This returns true if exactly one out of P and Q are true, right? So if you want exactly one of them true, you use XOR, exclusive or. If you want any of them to be true at all, you use logical inclusive or. All right, here's a table that summarizes the result. It's kind of hard to look at. But over here, these are the inputs and these are the results of the operations. So like um, if I want to check like this one right here, for example, not this. Um, so like if I want to, all right, so like let's say I'm trying to check this one right here. Like what does that mean to get this column in the table? So that would be, it's an and. So and the inputs are here, true, true. So what this is saying, the fact that this is true means they did true and true, right? Because the inputs are true and true. And then we do this and we hit enter and we get one, which is true. And that's why that's true. So if you slide this over to where it's false, maybe right here, like to get this entry right here, what they did was the input was true, and the operation was exclusive OR to get this one. So that's XOR true, true, and we get that that's false, and that's why that's a false there, right? So this is a summary of the and, the other and, the or, the other or, the exclusive or, and negation, which we haven't looked at. Did I? Oh, it's right here. I had negation right here. Negation is simple, right? If you do negation of true is false, and negation of false is true. So this should be pretty simple, right? If I do like not true, I get false. And if I do not false, I get true. And you can do it with zeros and ones too. So not zero is one, and not one is zero. All right. So those are your logical operators. Here's an example just to make sure we can work through them. We'll do this quickly because I'm being really slow here. Um, so what do we got? So I have some variables here, 1, 2, and 3. So X, Y, and Z are 1, 2, and 3. And we want to check if these are going to evaluate to be true or false based on what we know. And so to do these, I mean, you could type them in, but you could also do them just kind of as mental exercises here. So like if I take this first one, for example, and we try to figure out what it is, um, to try to figure this out, what you would do is mentally or physically replace the variables with what they are. So like X is 1 and Y is 2 and Z is 3 and Y is 2. And then you work out each one of these conditions based on what we know. So this says 1 less than 2. 1 less than 2 is true. And this says 3 less than 2. 3 less than 2 is false. So we have a true and false. And we have to remember how and works. So in order to be true, both of these need to be true, right? Both true at the same time to be true. They aren't, so this is false. And if you get confused about that, this should be false, that's what that table is for. So you go back up to the table, and if you look for true false, which is the third line here, true false is the third line, and true false and column right there. Okay. So you can do that for all of these just to try them out, um, see how they go. And I have the solutions right here. I'm not going to do more of that right now, but actually let's do the XOR version of it just to see if this makes sense. So if I do XOR X greater than 0, comma Y greater than 0, like that, and we fill in the numbers. Well, let's fill in the numbers. So X is 1, Y is 2, so we have this, and then mentally or physically fill these in. So 1 greater than 0. That's true. 1 is greater than 0. And then the next one says 2 greater than 0. That's true. So we have an exclusive or true comma true. And exclusive or true comma true is false. Remember, exclusive or means only one of them is true, not both. Only one of them is true. So that comes up false. All right, so that's how those work. Now we've only got 10 minutes here, or roughly. So let's see here. I'm trying to think. No, we can go a little bit longer, maybe 15 minutes or something. So what we got here are branches. So this is section 4.4 now. And so branches are very important. We use branches to make decisions. So every programming um, language has to have a way to do branches. They've been built into CPUs on your computer since the earliest days of computers. Um, in the earliest days, what they would have is they would have an instruction called jump, and it would be like there'd be an instruction called like JZ for jump if zero, and it would just look to see if there was a zero somewhere, and if there was a zero, it would jump to some place in the program, and if there was not a zero, it would do something else. Now we can write a lot more complicated branches than that, but the basic idea is the same. So the idea is uh, we want to do something under certain conditions. We use a branch. The basic branch we use is called an if statement. There's various forms of it. We'll look at all of them, although maybe not in this video. I might have to stop it and come back. But there's basically three different forms that I wrote here. There's if else, and if, else if, else. So this is like just the word else and if combined together. Um, Other programming languages don't write it this way. A lot of times there's a space between the else and the if to make it two words. MATLAB squishes them together into one word, else if, which is not a word. And let's see how to do this. Okay, so the structure of a branch, the most basic structure, and we'll look at this from the bottom up, right? So first the basic one, and then the bigger one, and then the bigger one. So the simplest if statement is going to be like this. If, then you write some expression. So this expression here is what we were learning all of these, like, I guess I erased it. It's why we were learning all these logical operators, right? Like, why were we looking at like the relational operators? Why are we looking at the logical operators, right? It's so we have something to put here in the if statement. So we have if some logical expression, the logical expression will be true or false. And if the logical expression is true, then we're going to run all these commands. So we run all these commands if the expression is true. And then when you get to the end, that's the end of the if statement. So you have to start it with if, and you have to end it with end. And the stuff inside only runs if the expression was true. So, I mean, I have an example on the other page. We could also just write an example. I have one here called branch test. Just going to delete it. Um, just to show you how it works. So I'll run a little script here. Um, so let's do this. If, let's do a variable, x equals 0, y equals 3. If, and you can use parentheses, but you don't have to in MATLAB. So I'll write it without right now. So if x is less than y, if x is less than y, then we type whatever we want to do. So I could say, I'm just going to print something on the screen. So I'll just say display x is less than 3. Lol. End. Right? So here's a very simple script. So x is 0, y is 3. So when you do this, if x is less than y, you're going to have if 0 is less than 3. which it is, right? 0 is less than 3. So when I run this, it says x is less than 3. Lol. Why? Because this expression was true. Because it was true, we ran all of the commands that I put inside of the if statement. If I make this false, if I make this statement false, like maybe I can make it false this way. Well, actually, let's just leave that. Let's just flip this. If x is greater than y. So if 0 is greater than 3, which is false, and I run it again, look what happened. The second time I ran it right here, it did not print out the words. So it didn't print out the words because this line never ran. So if the statement is true, you run the inside commands. Otherwise, you do not. And that's all an if statement does. Um, so like, what could you use this for? Like, I don't know. What if we did this? Like, what if we said, like x equals negative 17? And I say if x is less than 0, like let's say I don't want there to be any negative numbers. So I can do, if x is less than 0, x equals 0, right? Like this. And I run this command and I look at x is 0, right? If x is less than 0, we make x equals 0. And if I put in like a positive 17, oops, numlock was off. If I put in a positive 17 and I run this code and I look at x is 17. If I put in a negative 17 and I run this code, x is 0. So you see, oh, I don't know what I just did up here. Um, yeah, so if x is negative 17, then x turns into 0 because it checks if it's less than 0, which it is, and then it sets it equal to 0. So like a little if statement like that can make sure that your numbers aren't negative. If they're negative, make them 0. That's just an example, right? We can do whatever we want. So that's how it runs. And you can have multiple lines inside of the if statement. I only put in one. All right, so here's an example that's very similar to what I just did. So just looking at it, you can see what we did. X equals 3. If x is less than 5, display, hey, we did it. And when you run that, it's going to say, hey, we did it because 3 is less than 5. Now, if you change that to if x is less than 0, but keep x equals 3, this time it says if 3 is less than 0, which is false. Because it's false, we do not run the display command. You don't see it here. So nothing inside the if would run if the condition is false. And that's an if statement. Okay. Now, the more complicated version, slightly more complicated version, is an if else. So what an if else does is it gives you two alternatives. So if the condition is true, you're going to run the top thing, right? Like if we cover up the bottom part, um, well, okay. If the expression is true, then you're going to run these commands, 1, 2, 3, whatever you have up there. And the else means otherwise. So otherwise, you're going to run these commands. So you're basically giving two lists of commands here, right? So you're giving this first list of commands, which we call this a block, by the way. So we have if expression block number 1, and then we have an else, and then we have block number 2. And so what happens if the expression's true, you run block 1, and if the expression is false, you run block 2. So that's easy to show it working. So coming back over here, let's just change this. So if x is less than 17, display x is negative. And then I change this to an else, and then I'll display x is positive. End. So there's my fancy script. So it's either going to display x as negative or it's going to display x as positive, depends on what x is. So if I run it now, it says x is negative. If I change that to a plus 17, now it prints x is positive, right? So we have two alternatives. We either do the first alternative or we do the second alternative. Um, yeah, so we either do the first alternative or we do the second alternative. Um, yeah, all right. So yeah, well, we'll see them when we see them. So you can see that work. I guess this is the same example that I just showed you, so I'm not going to go over it. Um, but two alternatives. Now, the third, more complicated version of an if statement is very similar to that, but this time we still have an if, we still have an else, but now we're sticking an else if in the middle. And so what the else if does is if you have multiple things that you want to check, multiple things that you want to check. And so what it will do is it checks if the first expression is true. If it's true, we run these commands in block one. And I want to write this because I feel like it's hard to understand. So just looking at what we have here on the left. So if expression one is true, we run all of block one, which is the command one, command two. Okay. And we skip the rest of it though. So we don't run the other blocks at all. Okay. Now, after, if that expression was false, then we move on and we check the expression two. So if expression one is false, we move on and check expression two, which is in the else if here. If expression two is true, we run the command in block two, which are, I wrote command three and command four. Okay. And we skip the rest and skip the other blocks. Okay. Now in else, there's no condition to check. So um, if expression one was false, and also expression two is false, so they're both false. So if expression one is false and expression two is false, then we run whatever is in the else. So the commands in the else will run. Right? Now the point of this is the way that this is drawn here, I've got first block, second block, and a third block. One out of these three blocks will run. It's just a question of which one. So one out of block one, block two, block three will run depending on, whether the expressions are true or false. Only one block will run though. So That's why when I wrote out the words here and I said, if expression one is true, we run block one, and then that's it. The if statement is done. And so if expression one is false, then we look at expression two. So you are only looking at expression two if expression one failed to run. Okay, so you kind of need to see an example of this for it to make sense. So let's look at MATLAB here. So maybe we can do this. How about this? Let's do x equals 5. Let's do y equals 10. Okay, and here's what we're going to do. If x is less than y, display x is less than y. Okay, else if, actually we write it this way, else if, and I don't like it without parentheses. I'm going to put parentheses back. Other languages require parentheses, and in MATLAB, it's not required, but it looks nicer. So if x is less than y, display x less than y. Else if, let's say x equals y, we can display x and y are equal, and then change that to an else. And then what's the third scenario? Well, x is less than y, x and y are equal, or I guess x is greater than y would be the third possibility, and then I can do an end. So this is an example of an if, else block. And so if I run this, just CLC, clear that. So if I run this block, or if I run this code here, run, it says x is less than y. So the first branch executed because 5 is less than 10. Now, if I make them equal, 5 and 5, and run this, it says x and y are equal. So the first one did not run, but the second one did run, and it displayed x and y are equal. And if I make the first one bigger and run it, now it says x is greater than y because the third one ran. Okay, so there was no condition to get here for the third block. There was no condition to check. It was just by the process of elimination, right? Um, so you have to be careful with these because you'll end up in the else if if neither of the other conditions are true. Um, let me do another example of this. So let's just do x equals 7, and let's do this. X less than 0, x less than 10, yeah, that's fine actually. Right? So to get done here, something else happened. Um, so if you run this, if I run this right now, it says x is less than 10, right? X is less than 10. So it printed that. But first it checks this condition. So if I do like -5, for example, and I run this, it says, let me just get rid of the clutter. It says x is less than 0, which it is, x is less than 0. So that's true, and it ran this first command. Now, if you check this condition, is x less than 10? It is, right? Because x is -5 and -5 is less than 10. So this condition is true, but it does not run this because if it runs the first block, it doesn't even look at the other blocks. If it runs the second block, then it won't even look at the third block. And that's just how it goes. So that's how they work. So only one out of the blocks will run. Now, what do we have here? Let's go back to this here. Here's an example. This is what we just saw. This is what we just saw. This is what we just saw. We'll need to get into more details when we're actually using this for something. That's going to be it for now. What I will say is this. So like if I put like a 15 here and I run this and it says something else happened did, um, then that makes sense, right? But this else part is always optional. So like I can get rid of that and I can just have an if and an else if. And now if I put in like a five, if I put like a -5 and run this, I get x less than 0. If I put a +5 in here and run this, it says x less than 10. And if I put in like 25 in here now, both of these are false. And so when I run it, I get nothing, right? Nothing printed out on the screen. So you don't have to have an else. You can also have multiple else ifs. You can do multiple else ifs. So I can put like 10, 20, 30 there, change the text like that. And now if I run this, if I go if I go 5, x is less than 10. If I go 15, x is less than 20. If I go 25, I go x is less than 30. And if I go 35, nothing because there's nothing after that x less than 30. Okay, so that's kind of a basic introduction to these. Uh, from now on, basically from now until the end of the semester, we are going to be using if statements a lot, right? They're just a basic building block of every program. So, um, I'll try to get you some work to do on this in a lab or a homework assignment. And for sure, next week we will be doing a lot of this. All right.